The last type of combination we can do with functions is called function composition. It's denoted by this f circle g of x, which is read f composed with g of x. And f circle g of x is equal to f of g of x. When we talk about the domain of composite functions, the domain of f circle g, we first exclude all x not in the domain of g. Then we exclude x for which g of x is not in the domain of f. Composite functions basically take one function, in this case like g, and substitute it inside of another function like here f. And so we'll look at some examples to show how we work with function composition and put them together and so forth. Alright, we're going to start off with these two functions for f of x and g of x, and start by finding f circle g of x. So keep in mind that means f of g of x. So how we do this is we start with the function f, which is 5, and in the place of x we're going to put something, plus 6. Wherever x is located, that's where we're going to put the g of x function inside of the function f of x. So that would look like 5, and then g of x is the full thing of 2x squared minus x minus 1. So that's what it looks like when I put all that inside of the function f of x. We'll go ahead and simplify this. Mainly the thing we can do is distribute the 5 to each of the things that we've put there to get 10x squared minus 5x minus 5 plus 6. We'll go ahead and combine some of the numbers together to get 10x squared minus 5x plus 1. We're also going to look at g circle f, g composed with f of x. Now g is going to come first, and on the inside will be f of x. So if we start with g comes first, we'll have a 2, and then x squared was there, and then a minus x was there, and then a minus 1. But now, wherever x was located, we're putting the f of x, which is 5x plus 6, in its place. Okay, and so in order to do this, let's consider that 5x plus 6 squared is 5x plus 6 times 5x plus 6. So we have to actually FOIL that all together. So keep in mind then that that means we have to do 5x times 5x for the first. That would be 25x squared. We have to do the outer, which is 5x times 6, or 30x. We have to do the inner, which another 6 times 5x, or 30x. And then we have to do the last, 6 times 6, which is 36. At this point, I'm also going to take that negative, since that's in front of the other parenthesis, and go ahead and distribute that in. Negative 5x minus 6 minus 1 here at the end. I'm going to go ahead and combine some stuff together here and make it 2. And 25x squared plus 60x plus 36 minus 5x minus 7. And now at this point, there's a 2 still out there in front of the parentheses. That'll go ahead and multiply everything that I have there in the parentheses. So it'll turn into 50x squared plus 120x plus 72 minus 5x minus 7. And there's not a whole lot more left to do. We can combine some things together. The 120 and the negative 5x would go together to be 115x. 72 minus 7 would be 65. So all together, that's what it would look like when we're done. There's some other composition things we can do. Namely, we can do the composition with numbers like f circle g of 2. So here's how I'll do this. We can keep in mind that f comes first, and that's f of g of 2. Sometimes what I like to do here is to go ahead and calculate the g of 2 on its own. So g of 2 would be equal to 2 times 2 squared minus 2 minus 1. And that's equal to 8 minus 3, and that's equal to 5. So that number in here, the g of 2, is 5. So we'll calculate this as f of 5 instead. And if I calculate f of 5, that would be 5 times 5 plus 6. That would be equal to 25 plus 6, or 31. If we did this another way, let's say g circle f of minus 1. G would come first, composed with f of negative 1. G of f of negative 1. So if we want to, we can start with the f of negative 1, calculate that. That would look like 5 times negative 1 plus 6, which would be just positive 1. So this f of 1 inside there can be changed over to a 1, and we can calculate g of 1. G of 1 would look like 2 times 1 squared minus a 1 minus 1. And that's equal to just 0. A couple other functions here. We'll do the composition of these as well, starting with f composed with g, f circle g of x, which means f of g of x. If we put together f of g of x, we're going to have to take the f of x function, which is 6 over x, but where x was located originally, g of x will go in its place. So what that would look like is 6 over 3 over x. Here, notice how we now have a fraction underneath, and if you divide by a fraction, what I'm going to do is change that to multiply by the reciprocal. So, in other words, I'm going to take this and change it over to 6 over 1 times x over 3. And what that would look like is 6x over 3. And 6x over 3 divides to just a simple 2x. We're going to see something similar if we do g circle f of x, which would be g of f of x. Starting with the function g, g was 3 over, and we're going to put f of x over underneath there. So it would be 3 over 6 over x. So I'll change that from divide by a fraction to multiply by the reciprocal. 3 over 1 times x over 6. And that would turn into 3x over 6. And that would reduce down to just x over 2. So let's look at our functions here that we have for composition, f circle g and g circle f. And let's just use those to directly calculate things like f composed with g of 5. I can plug that straight into the function that was created for f circle g of x. That would be equal to 2 times 5, or 10. Similarly, g composed with f, or g circle f, of 1 would be equal to 1 over 2, if I plug it straight into that x over 2 function up above. This last one here says decompose the function h of x equal to cube root of x squared plus 1 into two functions, f of x and g of x. Okay, so what this means is we can take our h of x function and break it down into two functions that, when composed together with one inside the other, is still the same function. How we're going to do this is we need to look at the inside part here of the cube root, and let's give it a name. Let's say that we call a function f of x equal to the x squared plus 1. Also, let's go ahead and make another function called g of x as the cube root of x. This will be the part of the cube root, and the other function will be what's on the inside. Then, if we go ahead and put these f and g back together again as g composed with f, or g circle f of x, then we put the g function outside with the f of x function on the inside. So again, g of x is the cube root part, and f of x is the x squared plus 1 part that goes on the inside. So altogether, the g of f of x makes up the same parts as h of x. So that shows how the composition of the two functions creates the full function altogether. It's broken down, or called decomposed, into two separate functions.